In this example, we know 2 of the side lengths in this right triangle, and we're looking for theta. So we're looking for this angle measure. I'm still using sine here because I know the opposite length is 10 and the hypotenuse is 12. So I'm still applying this same equation. Sine of theta is equal to the opposite side length, which is 10, over the hypotenuse, which is 12. Now we just need to substitute, sorry, I already substituted in the opposite and the hypotenuse. Now I need to solve for theta. So this is a little bit different because theta is inside of sine. So to undo sine, I do something called sine inverse, which looks like sine with a little -1. So I'm taking sine inverse of sine of theta. Whatever I do on the left side, I must also do on the right side. So sine inverse of 10 over 12. So on the left side, that cancels out sine inverse and sine, and I'm left with just theta. That's what I'm trying to solve for. And then the right side, I need to type into my calculator. So sine inverse is also included on the Desmos Scientific Calculator. If I go here and delete what I have before. So on the left side, it has main, A, B, C, and function. If I type function, I have sine inverse. That's sine to the -1. So I just need to use sine inverse, and then I go back to main, 10 divided by 12. For this one, let's round to the nearest degree. When we're finding angle measures, I'll almost always ask you to round to the nearest degree, which in this case would be 56. So that means that theta is 56 degrees. Looking back at my diagram, that seems like a reasonable angle measure for this angle. It's obviously going to be acute because it's not the right angle in our right triangle. It has to be acute, and I can see that it's larger than the other acute angle, which means it should be greater than 45. So that seems reasonable.